In this first example, we can see we have a quadrilateral over here. We should probably recognize that this quadrilateral is a kite. It has this pair of congruent sides that are adjacent to each other. They're kind of connected to each other at x. And then it has this pair of congruent sides that are connected to each other at z. So it fits that description of what a kite is. So we're going to keep that in mind. This is a kite. And the first thing we have to do is find the measure of angle YQZ. So YQZ is this angle right in here. And so what we have to remember is that for kites, we have our two diagonals. One of them is the perpendicular bisector of the other. And in this case, it would be segment XZ is going to be the perpendicular bisector for segment WY. So what that tells us is that in this picture here, we have a right angle here. Now I put it there, but technically it's at any of these or all of these angles right here. So I put it at angle XQY, but it's also going to be down here in angle YQZ, so we can already see that what our answer is going to be here. But just to finish out that thought, if XZ is the perpendicular bisector of WY, that would also mean that segment WQ and segment QY are going to be congruent to each other. So we can see that our angle here is going to be 90 degrees. The second part of this question asks us to find the measure of angle YZQ. Okay, so that's down here. Well, to do this one, we're going to have to recognize that now this triangle here and this triangle here are congruent to each other. They're congruent because they have three sets of congruent sides. This side is congruent to this side is congruent to this side, and then this side right here, segment QZ, is the side of both triangles, so we could say that it's congruent to itself. So if these two triangles are congruent to each other, it means that all their angles would be congruent as well, or their corresponding angles, I should say. So if I have a 56-degree angle here for angle QWZ, then I'm also going to have a 56-degree angle right here for angle QYZ. And then to find angle YZQ, like this question is asking us, we can say, all right, 90 plus 156. I can do 90 plus 156. Not 156, I'm sorry, not 90 plus 156. It's going to be 90 plus 56. Let me just go back and erase some of that. 90 plus 56 equals 146, and then 180 minus 146 is going to give us 34 degrees. So 34 degrees would be the measure of angle YZQ down here. Last, we have to find the length of segment WY. So from here over to here, how long is that? We see that from Q to Y is 12, so we can label from Q to W as also 12 millimeters. And then so WY is going to be 12 plus 12, or 24 millimeters. Now, in this second example, we are looking at an isosceles trapezoid. This is an isosceles trapezoid because we can see that leg ED and leg FG would be congruent. They're made up of kind of congruent, two congruent parts here, two congruent parts here. So whatever length this indicates, this one line, maybe these are, it says here they're 8 feet long. So this is 8 and this is 8, so that would be 16 on that side. This is 8, this is 8, that would be 16 on that side. So we know that this whole thing here is 16 feet long. So that's going to be our answer to part A, 16 feet. When we have to find the length of DF in the second part, we're going to have to rely on the theorem that told us that for an isosceles trapezoid, the diagonals are congruent. And it tells us right here that the length of segment EG is 21 feet. Well, that's one of the diagonals, so that other diagonal would be the same length. So the length of DF would also be 21 feet. Now the last part of this example asks us to find the measure of angle DEF. So that is one of the base angles on this top base up here, angle DEF. I know that it would be congruent to angle EFG. So if I can actually find out what the measure of angle EFG is, that would also tell me the measure of angle DEF. So I'm going to look at this 77-degree angle down here, and I'm going to ask myself, why did they tell me that? Why did they tell me that this is a 77-degree angle? And the key is going to be remembering that if this line here and this line here are parallel, which they are because this is a trapezoid, this line could act, or this segment could act as our transversal. So going back to something we learned a while ago, these two angles, angle EFG and angle DGF, would be same side interior angles. And same side interior angles are always going to be supplementary when our lines are parallel. So that would tell me that the measure of angle EFG plus 77 has to equal 180. So if I subtract 77 on both sides here, the measure of angle EFG is going to be 103 degrees. But that will also be the measure of angle DEF, for the reason we talked about just a couple minutes ago. So there's my answer for part C. Angle DEF would be 103 degrees. Now finally, in this last question, it asks us to find the length of the midsegment of this trapezoid ABCD. And we have to remember that a midsegment joins the midpoints of the two legs. So the midsegment in this picture would be segment PQ, because P is the midpoint of segment BA. We can see that BP and PA are marked congruent. Q is the midpoint of segment CD, because CQ and QD are marked congruent. So that midsegment is going to be segment PQ. And we have to then remember that the midsegment length is equal to, so the length of PQ will be equal to half the sum of the two base lengths. So that would be, in this case, the length of BC added to the length of AD. So we'd be looking at half of 54 plus 33. So that is half of 87. And half of 87 is going to give us 43.5 centimeters in this case.